Hello and welcome to another Solana tutorial. Today we're gonna talk about Quasar. Or Quasar? I'm not sure about the pronunciation. I'm just gonna call it Quasar, like the supermassive black hole thingy. I don't know where it has its name from. But Quasar is a framework with which you can write Solana programs using zero copy. And zero copy is actually one of the most requested topics recently. So yeah, let's talk about Quasar and zero copy. By the way, zero copy, in case you don't know what that is, means there is 0 bytes being copied, so we don't copy anything, because 0 is how much we copy and 0 is nothing. I think you get that part. Okay, cool. I explained what zero copy is. Great. Good job, Andy. Thank you. Let's look at Quasar. Actually, no. Before we look at Quasar, let's define what we want to do. Because Quasar, as a framework, like Anchor, has a bunch of functionality. Obviously, I can't talk about everything in this video, so this is just an introduction to Quasar. And I will set myself a goal. I do want to rebuild a program that we built in the Getting Started series, where we did it with Anchor, and now I want to do it with Quasar, just to see the differences, both in the frameworks and then in the performance. And this video also builds on what we learned when we talked about serialization, because that's where we interpret the bytes. So to understand why zero copy is useful, you might want to understand serialization first. So do watch that video in the Getting Started series where we talk about serialization, and that one also builds a program. Actually, I'm going to show you. So serialization was day 6, where we built the same program again with Pinocchio. But the first time we built that program was actually on day 3, where we just had this mood account that stores a mood. And something like that I want to build as well today, but with a different framework, not with Anchor, but with Quasar. Blueshift GG, Quasar. Zero copy, zero allocation, Solana program framework. That's what we're going to have a look at today. So this is still in active development and it is not being audited yet. Just some disclaimers if you want to use that in production. But I'm assuming that if more people use that, they will officially release and audit that eventually. But today we just want to have a look at it, see if it's any cool. Because it seems like it's very similar to Anchor, like the way it does the instructions and also accounts that looks very Anchor to me. Just not quite Anchor, but very similar. And there's documentation here. Can migrate from Anchor. It has both toolchains available, the upstream and Solana. We did talk about this already in the video. Can watch that up there. But for today, we'll just use the Solana toolchain and it's gonna be fine. Yeah, I guess let's just install the Quasar CLI and then create a project. Can't be so difficult. Let's go. So, cargo, install Quasar CLI. Let's see if we have that. Yep, that's a thing that we can just download. Comes with a bunch of dependencies, as those things do. There we go. Quasar profile, IDL, and CLI. And the CLI is installed in version 0. Executable Quasar. Cool. So Quasar, do you live? You live. Build programs that execute at the speed of light. Is that why they called it Quasar? Is that a speed of light reference maybe? I don't know. Scaffold a new project. That sounds about right. Let's go. Quasar init. My first Quasar project. Boom. We. Next step. Yeah, we can cd into this directory and then we can build. Let's first see what we have here. So there's a cargo toml. That's what we're used to, I think. Yep, lib type is defined, paths and dependencies are defined. We need Solana instruction, Quasar lang from Blueshift Quasar, nothing unexpected here. And then there's a Quasar toml where you specify the toolchain, a project name, and the testing framework. So we test with Quasar SVM Rust. Cool. And then we have a lib and tests. Oh, where it just takes the ELF file and creates an instruction to process. Interesting. Thing comes with an entire testing framework as well, I guess. The program looks like this. It has an initialize instruction with a pair and the system program, and initialize does nothing. So this is what a Quasar project looks like, or a program. We have the derive account, and then there's an implementation for the initialize and the function initialize. Okay, so it is a bit different than Anchor. I'm not entirely sure what that actually does or when that's actually called, because it's also called initialize here. In Anchor, that's what we would have, the program that has all the instructions. Oh, I see what it's doing here. So the account, this thing, gets an implementation for the initialize function such that here we can call initialize. So that makes sense. It doesn't do anything. It just says okay. But okay, that's how you can neatly structure that. Oh, that's cool actually. And if we build it with tests, then it will also include the tests module here, where it will actually call this instruction. Gets the initialize instruction. Where does it have the type from? Directly from my client. Where does that come from? That's interesting. My Rust analyzer is already not happy. Failed to load source from dependency. Maybe I gotta build it once. Let's try. Quasar build. Let's go. Building. I like that. Do I like that? I'm not sure if I like it. It looks cool, but I'm more of a CLI guy that actually gets me the text. So what happened here? Failed to parse manifest. Oh, this thing again. But now my Rust analyzer isn't complaining anymore. Now it managed to get the thing that it wants. And now it's just saying it can't do this because it doesn't have the SO file. Okay, that makes sense. So either I use a more recent nightly release, or we're using Solana CLI 3015. Let's see if we have a more up-to-date. Let's update the Solana CLI as well, just so we're not using old stuff. Okay, now we're on 3.1.12. Will that then just work? Yeah, there we go. Magically, now it just works. Just had an old Solana version. And now we should have, oh, there's a bunch of stuff in target. The deploy, 2 key pairs. Once with a dash, once with an underscore. That's weird. I wonder which one is the right one to use. I'm not sure. But anyway, the executable, the ELF file is here. The client, oh, that's what it is. It also generates me a client, so a Rust library essentially, that allows me to then call those instructions. Yeah, it knows the accounts, puts the right account meta and stuff. Wow, that's cool. So we don't need to go through an IDL and Kodama like we do with Anchor, but with Quasar, it just generates a Rust library as well. That's nice. Very cool. We do have an IDL though, if we need it. Cool. And yeah, some build stuff. That's very nice. And do you now find that as well? Yeah, now you find that. Cool. We're all green. That's nice. So we should now also be able to say Quasar test, and then it should run that test that we have here, where it just checks that we get success from that instruction, which we should. Yeah. Test initialize, test passed. If the implementation of my instruction wouldn't say okay, but error for a program error custom 42. And then I test, whoop, the build completes, but the tests fail. Expected success, got custom program error 42. Ha! So that seems to be working. And we didn't even have to deploy anything here. The tests really just take the ELF file and run it through the Quasar SVM. So that's all local. But hey, that is actually pretty cool. But so far our program doesn't really do much yet. It has an initialize that doesn't initialize anything. We don't have a custom account. So let's add an account to this. And also don't do the error. How do you do accounts? Ooh, that's cool. You can add stuff to the program with Quasar add, like scaffold stuff. Like a vault or transfer. Do I want to do this, or do I want to write it myself? Add instructions, state and errors to your project. Let's see. Create an instruction, state or error. So I can just add a state account, because so far we don't have state. I just say Quasar add state and then the name mood, because I want to build the same thing. So now it added this state for mood, which has an address. It's just a template. And the same way I could also add an instruction, set mood, and that it would create in the instructions. I should have named that differently. That's cool that it just creates that for me. And like the initialize, it also just gives it a pair and the system program. And then it also adds it here with the next available discriminator. How fun is that? That's so cool. Wait, let me do that again with a proper name. I'm just gonna delete this again. Should have called it set mood like this. There we go. That's better. Okay. So we have state. That the state is never included in the lib. Guess I gotta also add that. So here we see we have an account. It's called a mood account. It has discriminator of 1. So there's a 1 byte discriminator, not 8 like Anchor does. And the actual value for this is also 1. For the instructions we saw, it's starting at 0 and then 1. For the state, it doesn't start with 0 because 0 is being uninitialized, because 0 is the default. If you create an account, it has all zeros, so you don't want to have 0 as an account discriminator. Yeah, so what do we want to store in our mood account though? We want to also store a U8 of the actual mood, similar how we did it in our getting started series. Why not? Let's do that. Alignment wise, it would be better to have the address first, although actually we also have a discriminator, so never mind the alignment. The alignment is already messed up. So that's what's being stored. How is it written? So now we need to actually implement our instructions. And it's a bit weird because the initialize instruction we have here, but the set mood instruction we have in the instructions now. Maybe I'll also move the initialize stuff into a separate file here that we use like this. And you'll have to have the prelude stuff. Perfect. So I just moved it in a file now, removed it from here. So this is now just the main program with the 2 instructions, 0 for initialize, 1 for set mood. And there it just calls the implementation from within the accounts, and they have their implementation here where we implement for that initialize account thingy the actual function. That's actually quite a nice setup. I like it. So what does initialize actually do? Well, it's gotta create that account. So first of all, we need to add that account here. And to understand how we do that, let's have a look at documentation. Derive accounts generates all parsing and validation at compile time. Every account is 0 copy. Fields are read directly from account memory, not deserialization or heap allocation. And that's exactly why we're using this framework, because we don't want any copying or memory allocation. And to really understand that, you need to understand the entry point. And I did make videos about that. Basically, we're not reading the data from the accounts and copying it into our local storage for working with them. We just leave it in there and directly mess with the data in there. So we don't need to copy anything. So let's go through docs. There's no duplicates per default. So if I have 2 accounts that have the same address, then I need to specifically allow for a duplicate. Here are the account types that I have. Signer is the same as we're used to from Anchor. The is signer flag must be set for this one. The account with a type, that's a program owned data account. That's what we're gonna need. Validates owner and discriminator. Nice. Unchecked accounts have no validation. System accounts, check that they're owned by the system program. That's for regular wallet accounts that hold sol but no data. There's a program interface. That's interface stuff is used mainly I guess for tokens or other accounts where we use interfaces, and sysvars. Okay, so what we're using now is an account with a type. So this is what we'll need. Mutability, if we want to mark the account as writable, then we say mute account and type. Or we can use this attribute account mute like Anchor does, but the preferred way is this. So let's do it like this. So we want our mood account. I'm just gonna copy what I have here. Same lifetime. Mutable, because I want this account to be writable, because I want to change it. And then I say account with type. What did I call it? Mood. And that we get from state here. That's the mood account type. If you're confused why I called it mood and mood, it doesn't really matter. It's just some data that I want to store. So this is just a data account that stores some data. in this case 1 byte for a mood, because that was just the example that I came up with in my Getting Started series. So I'm doing the same thing now. But you can do anything, right? You can store whatever you want. So we initialize a mood account. Now in Anchor, there's this init constraint that tells it to, hey, just create that account. Let's see if we have something like that in Quasar as well. Account constraints. Init, or init if needed. Creates the account via CPI to the system program. Nice. Allocates space, pays rent, writes the discriminator, and assigns the ownership to the program. All in one step. Nice. Both need a payer. If your struct has a field named payer, it's auto-detected. That's convenient. So I don't need to say payer is payer like I do in Anchor. Otherwise, you say payer is name of the account. That's cool. That's how Anchor does it as well. So that's nothing really new. We have an init and it takes the payer directly. And if it's someone else, then we need to say payer equals something. Nice. So it all looks very anchored. Space is auto-computed from account type, but we can override with space equals. That's also cool. And why can it do that to auto derive that from account type? Well, because it knows the size of the account. And in this case, it's easy because we don't have any variable size stuff here anyway. But even if we did, because it needs to know that stuff for being able to zero copy anyway, it must know the sizes. Let's see. Dynamic fields here. If we have variable length stuff like strings or vectors or something, then we can specify it with a maximum length, and then we'll just allocate the maximum length. Or we can use a tailing field. If we have it at the very end, then it will just use the remaining bytes for that field, but we can only do that with one element. So if we have one variable sized field in our account, then we can just put it at the end. But then we would probably need to somehow define the length of the account, because there it probably doesn't know the size. Oh, here it also talks about the tail fields. There, for fixed size stuff, it's all fine. For dynamic accounts, we use a length prefix. Oh, if we have tail fields, then we don't do any length prefix. That's why it's more efficient. That makes sense. Discriminator rules must be non-zero. That's what I mentioned earlier with accounts being uninitialized, having 0, and cannot start with 0xff because that's reserved for the event protocol. Okay, now I get it. Space is auto-computed for the account type, override with space for dynamic accounts or custom sizing. So dynamic accounts, they don't allocate the max size, but you'll need to specify the account size. That makes more sense. Okay, cool. But we don't have a dynamic account anyway. We can just say account init, and that's good enough because we do have a payer and we have a static size account. So it knows the size, it knows the payer is mutable. We also have the system program to do the CPI into. So that should just work, right? And then we don't need to implement anything in the initialize because that init constraint has all the implementation. I guess that's fine then. And then let's also implement the set mood, where we also give it the mood account. It also needs to be mutable. This time we don't initialize it. This time it will check that it has that account type. And in the implementation here, we actually implement ourselves. So how do I access my fields? Self.payer. Okay. Self mood account. There we can access the authority and the mood, which is the two fields of that account. Oh, actually, if we do store the authority, which it would make most sense to do that in the initialize, if we want to also write something to the account already. So let's say in the initialize, we also already store the authority. That's a 0 copy. So how do I set that? Can I just say self payer address? But here I need to do a copy somehow. Here I need to copy that address into here. How would I do that? Set inner. Static accounts. I can use a set inner, except the types you declared. Set inner. I can set the mood and the authority. I just want to set the authority, but I guess I can set the mood as well to 0. And the authority takes an address. So here I can then just take the self payer address. Cannot borrow as mutable. I guess I need to make this immutable. Is that fine then? I guess so. Still wonder how I can set the individual things, but I guess that's how I would write the address and initialize the mood with 0. And while we use that authority, we might as well make use of the has1. Checks that a field stored in the account's data matches the address of another account in the struct. The field names must match. So if I say has1 maker, then the escrow maker needs to equal the maker address. So in my set mood, I would do something like account has one authority, and then I would put the authority here as the signer. Then it doesn't complain anymore. I don't think I need the system program here. I'm not doing a CPI into system program. So there we go. And I also don't think I need to make this mutable. And then in the implementation, I would also just set inner, but that's weird because I want to just set the mood. How? Wait, because I do have pointers. With the 1 byte, it shouldn't be too bad. So I have the mood, which is a U8. And if I just deref that and set it to the new mood, which is a U8 that I take as input here. I think that's how it works. That's how Anchor does it. I think it's the same here. That doesn't work. Cannot be dereferenced. Wait, hold on. But if I write it directly, hold on. Cannot, it's again the thing with a mutable. Okay, borrow mutable. But like this, that should work. We're directly writing 1 byte into there because that's a pointer anyway. It points to the place in the input data where that mood would be deserialized from, but we're not doing serialization because we're doing zero copy. So we can't just directly write there. This directly points to the right place. So we're using zero copy. So that should just work, right? The same way it should also work with address. Just that it's a bit more complicated in copying the entire address. So I use that set inner just to see if that works. If we initialize it, we can initialize everything. That's fine. Anyway, so we set the mood to the new mood, which we get as instruction data. Seems plausible that that's how this works. Let's see if that stuff builds. Can you build this, yo? No, you cannot. This method takes 1 argument, but 0 arguments were supplied. Oh, because I didn't change it here. That's true. This method takes 1 argument. Maybe here I also need the new mood, which is a U8. And then I put that in here. Does that work? Yes. It's fun. Plus 4 kilobytes. It tells me how much it's getting bigger. How fun is that? Good. Then we need to update our tests, because now obviously this isn't working anymore. Missing fields. The mood account. Yeah. So you need a mood account. I'm also gonna just do a new one, just a new pub key, and then which account it actually is. Here it creates for testing an account. So this is what it does for the payer, and I'll do another one for the mood account. Although I don't, wait, since I'm initializing this anyway with the program and doing the CPI, maybe I don't even need this. I don't need to tell you which account it is and that has Lamperts, because you can pay from the payer address anyway. I don't need to define an account for that. That can just be a clean account up front. So that should actually work already, right? Let's test. Nope, that fails. Missing required signature. Oh yeah, because we're trying to create an account, but we don't sign for it. So for the mood account, we would need to sign as well. How would I do that here? The problem is that here, the mood account, it doesn't request as a signer because I'm not telling it that it should be a signer. But the system program does expect it to be a signer if it should init that account. So if you have init but no seeds, you know what, I'm just gonna quickly hack and set this to true here manually and see if the test would work then. No. Oh, because it rebuilds it. Okay, that's not helping. Can I manually force you to use that as a signer? Instruction counts. Can I just manually overwrite this as a quick hack? Yeah, then the test would work. So I need to tell it, hey, please sign for this mood account. Again, we're just doing testing here. Like this, we're not actually sending instructions. This is just the tests. And we also just check for success. So we don't really see if anything happened with that account. How can I do that? This result, can I somehow check the accounts? Account, address, mood account, unwrap, and check the data. Let's see if we get the right thing here. Nope, unwrap. This is none. So there is no account. Mood account doesn't exist. That's not good. Okay, what if I created the account like this as well? If I say, oh, the mood account is an account that has 0 lamperts, no data, is owned by the system program, just so you have it in your database or whatever you're doing. Okay, then that works. Okay, we assert that the mood data 0 equals 1, otherwise account discriminator mismatch. That test is still complete. Let's just double check if it had a different number here, then it would fail. Account discriminator mismatch. So the data seems to be correct. So I'm checking for the account discriminator because my mood account will have discriminator 1. I can also check the authority, although here I'm just using a vector. There's probably a nicer way to do this. This probably also gives me, no, it just gives me the instructions. It doesn't give me any state stuff. Okay, 2 to 34. Can I make an address from that? Try into. Can I just do this then? New from array maybe? Let's see. Let's also assert that this address matches my payer address. Otherwise, authority address mismatches. Let's see. And also that test completes. Look at that. If I would compare with the mood account address, then that test should fail. There we go. So also the authority is correctly written in that account, in the mood data. Nice. And then we can also test the set. So that was the initialize. Now let's test the set mood, where we have an authority and the mood account again. And that's a set mood instruction that doesn't take the system program. Oh, new mood also goes into here. That's cool. And the new mood is 5. I'm 5 out of 10 or 5 out of 5, whatever. We call that instruction. We define the authority account that it has some sol and is a system program account. And the other one, the mood account, this time we define whatever. It also has some lamperts. It doesn't matter how many really. And we define the data. Well, there we need to have the proper mood account written now. Let's start with a vector with 34 zeros. And then we see that it doesn't work correctly. And the owner of that account will be my program, which I have defined. Where did I define the program address? Create ID. This will be my program address. So the program owns this one. And then we check that it has result. We check again the mood account, the discriminator. We can check the authority address. And most importantly, we will check the mood that it's set to what we set up here, 5. Setting mood failed. Let's test this. Obviously, this is not going to complete because we don't have the correct account data. Also, it's missing a required signature. Wait, why is it missing a required signature? Because I'm not signing for the authority, but I should be signing for the authority. Wait, I don't need to sign for this one now. Hold on, test again. There we go. We had a signature where we shouldn't have a signature. Anyway, we are getting invalid account data. There we go. Yeah, that's what I thought that it would give us because we have zeros and that's not the account data that it expects for the set mood instruction. Okay, so we need to set the correct data here, which is a bit painful, but the discriminator is 1. The mood uninitialized is 0, and then we need 32 bytes for the address. So that's the authority address. Can I say 2 bytes and then flatten this somehow? It's not TypeScript. I guess I'm gonna do this in 2 steps. This is just for testing anyway. There we go. Rust, man. Okay, so I write that data in there and then I set that data for that account and then maybe the test works. Huh! Test works! Yes! Nice. We wrote a nice little test that actually asserts that we've written the mood correctly. And if we were to check that for a different mood, then the test would fail. Yes! Because setting mood failed, 5 isn't 3. Nice! There we go. So we see that that works. That's just local testing though. We haven't actually checked that that is a working Solana program as well. Maybe Quasar just pretends it is. So let's actually deploy this as a Solana program. Quay. I want that to be my program. The funny thing is I don't know which one of the keys to overwrite now. This one or this one or both of them. I think the one that has the same spelling. So target deploy, the one with the underscore, and then dash. That's usually how it is, right? There we go, this one. Okay, change the key here. Do I also need to change it in the Quasar then? No. Do I also need to change it in the cargo then? Nope. Okay, I think that should be fine. I also want a key for myself. And the deployed project isn't so big. It's 6.9 kilobytes. So that should be deployed in 6 transactions. NDG, I'll take that. Config set for devnet and this key. So a sol should be enough. There we go. Let's build again and then see if that thing has a deploy as well. It does. What key does it use to deploy? Oh, it's still deployed to that address. Maybe I changed the wrong thing. Yep, NDG, I paid for this. Yeah, that's okay, it took that. So it's still deployed to here. So maybe the Quasar... Interesting, hold on. What if I do Solana program deploy the target deploy my first Quasar project SO? 7 transactions. Then it deploys to Quay. Cool. So apparently Quasar uses this key, this one with the dashes, and the Solana CLI uses the same underscores as the SO file dash key pair. It's a bit weird, but it is deployed to that address and also to the other one. And I can now also test it like that. Oh wait, you know what would be cool if you could upload the IDL as well. So the Quay is now also deployed. I want to upload the IDL. Copy. Write IDL to program ID. Let's see, just to see if that's an IDL that is useful for that. So that's my program ID. And the IDL lives in target IDL and then this IDL JSON. Let's see. Yeah, install that, why not? Could not resolve. While resolving undefined. Solana program method it. Okay, let's go. Let's do, but this it can resolve. There we go, that works. It's just the add latest. Maybe the add latest is a bit confusing. Okay, getting somewhere. Now I just need the right path. Here you go. Let's see again. That's looking better. Success. Operation executed successfully. And if we now refresh this, maybe it will have an IDL. Not yet. Well, I guess it's then just gonna take a while. I was hoping I can just use it here then with my wallet, but fine, let's do it with a script, as we usually do. A new text file. So we are going to call this program with the following data: 0 for initialize that account. That's going to be our mood account. So what do we need? First we need our payer address as writable signer, then our mood account also as writable signer, and then the system program. But once again, I'm too lazy to import that. System program as read-only. That's for the initialize. And then let's do a set mood right after. So the 1 is the discriminator for the set mood. We again use the payer as a signer. So that's the authority this time. Same mood account. We don't need the system program. We also don't need this one as signer anymore. And then we send this. We'll put that in a transaction, simulate, and send this. Let's see. I think I still need to add the signer of that mood account though, because I'm building instructions manually. I think I need to say add signer to instruction, the mood account. Oh, not down there, up there. This one. And that's the instruction. There you go. Then that should work. I made that mistake so many times that this time I'm not gonna make it. So I'm signing for that mood account such that that's actually a writable signer. The payer is the fee payer anyway, so this will sign in any case, so that should be fine. Let's call this Quasar program. And missing required signature for instruction. Still? Damn it. I thought I had that down. System program got invoked. That worked. But then the second one is missing a required signature for instruction. You also wait, what? Which one are you missing a signature for? Let me see my program again. You need the authority, which is a signer, which should sign, and then the mood account, which has the same authority. Yeah. Why is it not working? But the first one was working. Okay, let's just do the first one then for a second. See if that works. That works. That gives me success. So I can create this account. And this account, I still can't look at it like that. If we Solana account this then we do see that the discriminator was written and the authority was written. We don't have a mood written to that yet. It's interesting. Do you also need me to add that as a signer? That would be weird. Would that work then? No, still missing required signature for instruction. That's not what it is. What signature are you missing? Can you dump me that transaction message? Let's check this in the inspector. We have 2 valid signatures for both Andy and that other weird account. If I simulate that, indeed, missing required signature for instruction. But what? Both of the accounts are signers. Why are you giving me a missing? I don't get it. Both of those accounts are signing and both signatures are valid. Program returned error, missing required signature for instruction. That is very strange. Maybe it's saying that the authority isn't the same. Set mood. You need the authority and you need the has one authority. Let's deploy this again. Now it's also deployed to this one. Nope. What if I don't have that constraint? Just to check where my issue is. What if I deploy this version? Now my program is smaller. I have a check less. It still says missing required signature for instruction, so that's not it. Missing required signature for instruction. What? What the hell? Oh, wait, I think I get it. Wait, take this back, put it back. I know what the issue is. I am saying you have instruction data. And because we're using zero copy, obviously we're not checking all the things, we're just expecting them to be there. What happens if they're not there though is that we're misaligned. So if our instruction data is smaller than what we expect, then I'm reading a different byte for the account or whatever it's misreading, and then I don't have the right signature for that or whatever. So what I'm doing wrong is when I'm calling my program, I don't have the new byte for the mood or whatever data I'm setting. So set that to, I don't know, 9 out of 10 and do that. Then that should hopefully work. No, it doesn't. It's the same thing. For real? I thought I had it. I don't. Damn! I felt so close. And yet I'm so far. Oh, what the hell? What if I say you are writable signer? Does that change anything? No. Maybe I'm messing something else up. But it's good that we're trying this because it seems like such an easy program, but I mean, at least the initialize works. I wonder why the set mood doesn't work. Maybe just that thing doesn't work. But we tested that in the local test and that was fine. Okay, so what's the error if I call something completely different, like 2, instruction discriminator 2, invalid instruction data? Okay, can see that, invalid instruction data. What if I put more instruction data here? Instruction data comes at the end anyway, so that shouldn't be the issue. What am I messing up here? This is very weird to me. Okay, let me try something. Testing. Cargo init a local lib. Wait, I don't actually need a lib, I need a main. And in that main, I'm gonna do the same thing that I did here. I'll just see if I can get that to work. And I'm manually gonna add the dev dependency to my own project with the path here. Yeah, that works. Great. I just add that to the path here in my dev dependencies, or maybe in my real dependencies. Does that help then? Yeah. But that gives me a proper instruction. Hint, it includes the Quasar SVM instruction, which might be, it is the same as the Solana instruction. Okay, that's perfect. So I can also just cargo add Solana instruction and import that from there. Okay, great. Let's just take those 2 random addresses, build an instruction with it. And then I want to print, because I didn't manage to print with my tests, whatever I can find in instruction data. Really, I'm just interested in what instruction data I'm supposed to put for this. Let's see if I can run this. I mean, it's that simple. It's 1 and 5, as I expected. So nothing special here. Okay, fine. Let's see how I can send this instruction. Oh, vibe coding. I'm making it easy for myself. I'm gonna connect to DevNet. That looks right. I fetch a block hash. That looks right. We're gonna build and sign the transaction. That looks right. We're gonna send and confirm. That also looks alright. Then we need to add Come on, cargo add Solana client, Solana transaction, and with all of those things added, there we go. We have all those things. Isn't that nice? Let the Rust analyzer do its Rust analyzing. There we go. And now we should be able to import that stuff. There we go. So we read the key pair from that file, and then we create this same instruction and try to send the transaction. Now with Rust, with that very client that we built with our Quasar, this client, this instruction. Let's see if we can do that. Run it. Oh, and by the way, this account, that's what it looks like with 1, 0, and then my authority. Let's see if that actually changes it. Let's see if we can send that transaction. It builds, and drum roll, please. Transaction success. What? This one is successful? What? You just sent the transaction. The unknown instruction actually returns success. 58 compute units. That's what you get for not doing any serialization, but just doing zero copy. 58 compute units. That's pretty efficient. And did the thing work? Does it? No, it did not. It didn't do the thing that it's supposed to do. There should be a 5 here now. Wait a second. Does that count? Or did I? Wait, but also maybe. Hold on. Did I? Wait. Maybe I still have it deployed with this disabled. Yeah, whoops. Of course it's not doing that if that was commented out. Sorry about that. Let's run it again. Now we'll need 60 compute units or something. Let's check. Yeah, look, actually 60. We use 60 compute units. Oh, also, do you see where the compute units are at the very bottom? They did the thing that I complained about. It used to be somewhere up here, which annoyed me, and now it's down here where it doesn't annoy me so much anymore. Great, nice fix. Thank you, whoever did that. Probably Jonas. Thank you for that fix. Cool, anyway, so now we need 60, so that's 2 more, but therefore we actually write to that account, and now there's the 5 here. So that works. Okay, so with Rust, I can actually create this instruction and it also works. But then my question is still, what am I messing up with my kit script that I have here? It's gonna be the last order of business. Let's check this in inspector. Here we only have one signature by Andy, and that other account is not signing at all. Well, let's try to do this same thing then with my TypeScript. Let's not create a new account for this, but say that's the address that I want to use. And we don't do the initialize, we just do the set mood. Would that work? That does work. Okay, so hold on then. Okay, also 60 compute units, and now that account should be at 9. Yes, mood 9 out of 10, because that's what we set here. Okay, to get to 10 out of 10, I want to still be able to explain why it doesn't work if I have both of them. Maybe it doesn't allow that account to be a signer in the set mood. It's a weird error message, missing required signature for instruction. But maybe what that means is in the set mood, it doesn't allow this one to be a signer because it's just a mood account. It's supposed to be just a mood account and not a signer. That would also be weird. It should just ignore that, no? Validation pipeline. When an instruction is involved, header validation. Signer, writable, executable, and duplicate flags are checked against compile time expectations of a single constraint comparison per account. I guess that's the case then. Okay, so if in my Rust script I would have 2 instructions, so one is the set mood instruction and the other one is the init instruction, which is an instruction of an initialize instruction with the same mood account, pair, mood account, and system program. Default is the system program. Expected instruction found initialize instruction. Call into, there we go. And then I would add the init instruction here as well. Then you would probably tell me that I'm not signing for the mood account, which makes sense. Yep, missing required signature for instruction, because I'm not signing for this one because I can't. I would need to keep pair new, something like that. And then I can theoretically sign with this by putting it here, the mood signer, and like this. Failed. Keep pair pub key mismatch. What? Oh, because, wait, what? Probably because you don't expect this to be a signer. So I need to do the same thing again. The hack that I already had here in my test to set the account is signer to true. Otherwise, it doesn't need it as a signer. Quick hack and recheck. Now the instruction 1 is saying missing required signature for instruction. And that's exactly the same error that we had there. Yep. So I think it's also saying to me missing required signature for instruction when I'm providing a signature too much. I think that's my issue. Let's see if I made that thing a signer as well. Can I make that a signer? Can I require this to be a signer? Just gonna try something real quick. Mood signer is a signer, and I'm gonna allow this to be a duplicate. Requires a check because I wanted a signer and I don't know how else to do it. Let's see, lol. And I'll just add this account double, once as a read-only signer and once writable. So as a writable signer, would it then work? Yes, that's actually the case. Look, now I can create this account and at the same time set the mood because now it is a signer. Okay, here's my conclusion, because now it's okay with this being a signer. So it's cool because we're trying out the thing. If we don't have that dupe here, then it will not allow us to do that because we'll have a duplicate account. And then it says instruction tries to borrow a reference of an account which it already borrowed. That's the error. Okay. So we see that per default duplicates are not allowed. And we also see that a normal account with a type doesn't allow that to have the signer flag set to true, and it will error with missing signer, which is just a bug. This, I tell you, is just a bug in Quasar. So I shall hereby report this as a bug. But we do understand why that's happening. Let me redeploy this with this fix. It's ugly. You will not need to do this, I hope, because they will fix that. They will fix that. I'll tell them to fix that. Once that video is out, you probably don't need to bother with this anymore. But it's cool for us to see that we managed to figure it out. And then also, now my main, see, this is not working anymore because now I also need the mood signer here, which is just going to be the same thing again. But this way also here this one should work now. And you know what? I'm going to set it to 10. I'll set the mood to 10. There we go. That's my signature. It does work. I can do both the initialize and the set mood. Yeah, setting it to 10. This is the account that I'm creating. And if we check 0A, 10 out of 10. We are very happy with this. Okay, great. I think that's good enough. There's a bunch of stuff that we haven't had a look at, like pod types and whatever, talking about alignment. I might make yet another video about this because Quasar really seems fun and like a cool framework where you can write pretty efficient implementations for stuff. So yeah, I like this. And the CLI is also pretty cool. You can add instructions or errors or state. We really just scratched the surface with our little program here. It's really not a complicated program. It has an account with 2 fields that have static length. We could write a much more sophisticated program. Let me know if you want me to do that. But yeah, I will call it for today. Quasar is pretty cool. 0 copy for the win. Here's some other videos you can watch. Give this one a like if you enjoyed it. Subscribe if you haven't already. And I will see you in the next one, where we build another program with Quasar. Or do something else. We will see. Till then, bye bye.